Hydropower is a renewable that we would likely not be directly specifying, but I do have some examples of what could be um, residential level hydro systems. So obviously, hydro has a long historic past. The idea of either damming or creating a weir in a river to turn a water wheel to grind wheat from our earliest days of settlement. And in modern times, obviously, when we talk about hydroelectricity, we use it to generate electricity. Once again, I remind you that this energy is still coming from the sun. So many of the aspects that drive hydro energy or hydroelectric production are related to sun and climate. So with climate change, there are effects to how hydro systems perform, and we'll kind of get into that as we move along here. So the basic concept here, just as I was talking about extracting water with a water wheel from a stream, we now have a little more sophisticated designs to our water wheels. We refer to them as turbines. But instead of now generating or driving a mill to grind wheat, we have coupled it to a generator to create electrical energy. And I don't know if these are all hyperlinked. These go from a presentation that I found on this. I would hope that I had a hyperlink to it. Doesn't appear that I do, so I apologize. I might add that to the slide pack. So we have two basic concepts of the ways that we extract. When we talk about this, it's important to keep in mind that these have environmental impacts to them also. In Western New York, we are next to one of the largest hydro installations, I think, in the Northeast. And that is we have used the Niagara River um, to use the run of the river, although we have created a kind of form of damming by creating a reservoir to generate electricity. And this is very much what the Niagara Hydro project looks like. We have a Lewiston Reservoir, a spillway to what's called a penstock to go through a turbine and be discharged at a lower level into the river, the Niagara River, before it goes. Well, this will be after it's gone over the falls. And then we generate electricity. We step up the voltage of it and push it out over transmission lines. But we can do that by just intercepting the run of a river. One of the reasons why we dam, or we created a reservoir for the Niagara project, was to create a stable amount of electrical flow at all times of the day and all times of the year. And the issue there was the amount of water going over Niagara Falls. We wanted to keep at maximum output, so we don't remove water for hydropower during the daytime. We only do it at night, and we use it to actually generate electricity directly and also use it to fill the reservoir. So the reservoir in this case is acting as a short-term battery. So we have many different scales of hydropower systems and the associated amount of electricity that comes off of them. At their highest level, it's enough to serve a large population. We're talking 1.3 million people. Remember, there's 300 million people in the United States, approximately. And this is just an idea of that scale of the Hoover Dam, one of the largest man-made dammings and restrictions of a river in order to create hydropower. So it's important also to know that hydropower is a really significant part of our renewables. When you look at the whole percentage of renewables or the whole makeup of renewables, keep in mind though that our renewables are still a small fraction of the electrical and energy that we produce in this country. Most of our energy still comes from gasoline, coal, and natural gas. So there's benefits to it and there's concern. Obviously, this idea of um, cost competitive, reliable. Um, Many of these projects have been under the guise also of being valuable for flood control, like the Tennessee Valley Authority projects. Um, but there are many concerns that come along with them also. And in this case, this is um, just a graphic of the idea of spawning of fish, damming of rivers, and creating of reservoirs, destruction of natural ecosystems and habitats. We also have, with climate change, this concern of failure of these systems because of the huge impacts of heavy, high energy rainfall systems. We're seeing increasing um, extreme events that are rupturing and or breaking down the man-made barriers that are holding back the water, the the soil the soil systems and the concrete systems are beginning to fail, overrun to areas that aren't anticipating being flooded are now being inundated with water. So there's a safety concern with some of our pre-existing hydropower systems. They also have a requirement for this idea of embodied carbon. Many of the large-scale hydro projects require massive amounts of concrete to create dam systems. Um, and concrete has a really heavy footprint environmentally in the production of um, carbon dioxide through its production. So, well, with all those negatives, I wanted to also kind of give you some small scale views of hydro plants. I thought this one was especially beautiful. Oops, I went right by it. I'll just play a little snippet of this. And I hope the sound's coming through because I thought it was a really beautiful small scale hydropower system. I think it's important to look at it just because of the low speed that it's churning at. Obviously, this is not residential small scale, but this is small community scale. This could be very useful in a rural, undeveloped area that needed some sort of electricity. This runs for a few minutes. I invite you to use that link. I'll get rid of this ad here. It goes in to show you um, how small the system is on the inside. So this is that's the electrical generator power output coming. So here's the generator that we're seeing right now that generates the electricity. The gearbox over here that takes the small speed of the rotor turning and turns it into a higher speed to turn the generator. So you can see how slow the shaft speed is for the turbine screw. And then back here we have an electrical distribution. This is probably a step-up transformer and the electrical control panels for that distribution system. And hopefully I can get out of this. There we go. And then we'll take a look at this one other slide. This is actually just a very small water generator placed in a stream to generate some electricity. Very small scale. So, and obviously the related low power output. We're not going to power the lighting system of the city here. So you're invited to watch this at your convenience from that slideshow. And that covers hydropower. And next we'll pick up geothermal.